So, you know how we've been looking into Lambda functions for our new project? It's really interesting to see how much the landscape has changed in just a few years.
Yeah, it does seem like a big shift from traditional servers.
Absolutely. She amazed. The idea of serverless computing is fascinating because it abstracts away so many of the infrastructure concerns. But there are some trade-offs that can be pretty significant if you're not careful. For example, cold start times can be unpredictable and sometimes quite long.
That sounds frustrating, especially if your app needs to respond quickly all the time.
Exactly. And then there's also the issue with debugging. When your code runs on someone else's infrastructure, it can be tricky to get full visibility into what's going wrong when things break. Plus, costs can spiral out of control if you don't have a good handle on usage patterns.
Costs definitely need careful consideration. I guess monitoring and scaling become even more important.
Oh, absolutely. Monitoring becomes crucial because you have less direct control over performance and resource allocation. You need solid metrics to understand how your application is behaving under load. Also, think about the fact that state management becomes harder in this model. Stateless functions are great for scalability, but handling sessions or user data across multiple requests requires extra thought.
State management does sound complex now compared to regular servers.
Indeed, it adds another layer of complexity. But let me tell you a joke. Why do programmers always mix up Halloween and Christmas? Because Oct 31 equals Dec 25. Nay.
Ha! Nice one. I haven't heard that in a while.
Right? Classic programmer humor, de. Anyway, back to Lambda functions. Another thing to consider is the limits imposed by the provider. Like memory size, execution time, you name it. These constraints might force you to design your architecture differently than you would with traditional servers.
That could be challenging for bigger applications.
Definitely. Oh. It means breaking down tasks into smaller chunks, which can introduce overhead in terms of function invocations and inter-function communication. But hey, these challenges come with benefits too, like automatic scaling and reduced operational burden once everything is set up properly.
True, those benefits are tempting given our current workload.
They sure are. Just remember to weigh them against the downsides carefully before diving in too deep. We should probably run through some use cases together later this week to get a better feel for where Lambda makes sense for us specifically.
Sounds like a plan.
Great! Now let's take this shot here. I love how the light hits that building at sunset.
Beautiful indeed.
Speaking of benefits, let's talk about the advantages of serverless architectures. One of the biggest perks is the automatic scaling. You don't have to worry about provisioning servers or managing capacity. The cloud provider handles it all for you.
That does sound appealing, especially during peak times when traffic spikes.
Exactly. And it can significantly reduce costs, since you only pay for what you use. No more paying for idle servers, sitting around waiting for requests.
Cost efficiency is definitely a plus.
Absolutely. Plus, with serverless, you can focus more on writing code and less on maintaining infrastructure. This can lead to faster development cycles and quicker time to market for your products.
Focusing solely on code sounds like a dream come true.
It really is. Another benefit is the improved reliability and fault tolerance. Providers often replicate functions across multiple availability zones, reducing the risk of downtime due to hardware failures or regional issues.
Replication across zones must add a layer of security too.
Indeed, it does enhance security and resilience. Also, think about deployment simplicity. Rolling out updates or new features becomes easier without worrying about rolling back servers or dealing with complex rollback strategies.
Simpler deployments would make our lives much easier.
For sure, it allows developers to concentrate on innovating rather than fixing underlying infrastructure issues. Now, let's take this photo of the skyline. It looks stunning right now.
Perfect timing. The view is breathtaking.
Absolutely, the view is amazing. But let's get back to scalability in serverless environments for a moment. One of the key strengths of serverless architectures is their ability to scale automatically based on demand.
That seems like a huge advantage, especially during unexpected traffic surges.
Exactly. Unlike traditional servers where you might need to manually adjust capacity, serverless platforms can handle sudden spikes in traffic by launching additional instances of your functions almost instantly.
Instance scaling must be quite reassuring for high-traffic applications.
It really is. The cloud provider manages all the infrastructure scaling behind the scenes, which means you don't have to worry about over-provisioning or under-provisioning resources. This can save a lot of headaches and costs.
Over-provisioning definitely leads to unnecessary expenses.
And under-provisioning can lead to performance issues and unhappy users. In a serverless environment, the platform dynamically allocates resources as needed, ensuring that your application remains responsive regardless of traffic volume.
Dynamic resource allocation sounds very efficient.
Very much so. Another aspect is the granularity of scaling. With serverless, you're essentially scaling individual functions rather than entire servers. This allows for more fine-tuned control and optimization.
Scaling individual functions could be more precise and cost-effective.
Precisely. Plus, since each function runs independently, you can optimize and scale different parts of your application separately based on specific demands. This level of flexibility can lead to significant improvements in both performance and cost management.
That kind of flexibility would be incredibly useful.
Absolutely. Let's make sure we capture this angle of the building. It looks great with the evening light.
Perfect shot. The light is really bringing out the details.
Capturing this angle is perfect. Now, let's talk about the cold start phenomenon in serverless environments. It's a common issue that can impact performance, especially when traffic isn't consistent.
Cold starts sound like they could be a significant bottleneck.
They definitely can be. A cold start occurs when a function is invoked after being idle for some time, and the system needs to initialize the environment before executing the function. This initialization can introduce latency, which can be noticeable during the first request after a period of inactivity.
Latency due to initialization sounds like it could affect user experience.
Exactly. While modern cloud providers have made efforts to mitigate cold starts by keeping functions warm or reducing startup times, they still occur and can vary depending on factors like region and provider-specific configurations.
Keeping functions warm would help reduce those initial delays.
Yes, one approach is to implement a keep alive mechanism, where you periodically invoke your functions to prevent them from going completely idle. However, this adds operational overhead and potentially increases costs slightly.
Periodic invocation does seem like a practical workaround.
It is, but it's not always ideal. Another solution is to optimize your functions for faster startup times by minimizing dependencies and optimizing code size. Some providers also offer reserved concurrency options, which can help ensure that certain functions are kept ready for immediate use.
Optimizing for faster startup makes sense.
Definitely. Understanding and addressing cold starts is crucial for maintaining smooth performance, especially in applications where low latency is critical. Let's take another photo here. The reflections on the water are beautiful today.
Stunning. The reflections really add depth to the scene.